Okay, students. So we discussed the lesson. Then we did the questions in your textbook. And I told you all I'll be discussing some more extra additional questions. So now here are the questions. When I display the questions, you can answer it first and then you can listen to the discussion. So I'll start with the first one. Extra question 1. Write equations for the following terms. And the first one, atomic mass unit, second relative atomic mass, and then relative molecular mass. Here look at the question. They want you to write equations. So no need to give the explanation, you write the equation only. What is atomic mass unit? You know, 1/12 into mass of 12,6 carbon atom. That is the equation for atomic mass unit. Then for relative atomic mass, so I will write the shortened form here. Relative atomic mass, that is equal to mass of an atom of an element divided by what? That is the atomic mass unit. So you have to write it as 1/12 mass of 12,6 carbon atom. So that is the equation for relative atomic mass. Then for relative molecular mass, what do we write? Relative molecular mass, students, here to save space I am writing the abbreviation RAM, RMM for relative molecular mass. What do you write on top? Mass of a molecule of an element or compound. You know why we have to specify both. Mass of an atom, of an element or a compound. Divided by what? Again, 1/12 mass of 12,6 carbon atom. That is the relative molecular mass of substances. So I am sure you wrote all these equations correctly. Then I will move on to the next question. Extra question 2. Mass of an atom of sulfur is given to you. So mass of an atom of sulfur is 5.332 into 10 to the minus 23 grams. The true mass of a 12 carbon atom is 1.99 into 10 to the minus 23 grams. Calculate the relative atomic mass of sulfur. This is a very direct question. So what do you need to do? You need to write relative atomic mass of sulfur. Sulfur, that is what you need to find. So what is the equation? Mass of sulfur atom, or you can say mass of an atom of sulfur. It both means the same thing. Then what do you divide that with? 1/12 mass of 12,6 carbon atom. And here both values are given to you. So the mass of sulfur 5.332 into 10 to the minus 23 grams. You divide that by 1/12 into mass of carbon 1.99 into 10 to the minus 23 grams. Grams cancel off, 10 to the minus 23, 10 to the minus 23 cancel off. So you will get the value as 5.332 into 12 divided by 1.99. And when you simplify this, what will you get? You have to do the calculation. You will get the answer as 32. So that is the relative atomic mass of sulfur. So this is a very direct calculation, students. They can give you the mass of the atom, mass of carbon, and ask you to calculate the relative atomic mass. So directly you have to write the equation, substitute, and find the value. I am sure you were able to do this. With that, I will move on to the next question. Extra question 3. Fill in the blanks and complete the sentences. So, relative atomic mass of nitrogen is what? You all know it is 14. There are blank nitrogen atoms in 14 grams of nitrogen. How many nitrogen atoms are there? When you take 14 grams, there will be Avogadro number. What is that? 6.022 into 10 to the power of 23 nitrogen atoms in 14 grams of nitrogen. Relative molecular mass of SO2. So, what do you need to know here? Sulfur and oxygen, the relative atomic masses. Sulfur is 32, oxygen 16. I will show you all here. So, sulfur 32, oxygen 16 into 2. This is what you have to add. So, 32 plus 32, it will be 64 there. So, relative molecular mass of sulfur dioxide is 64. There are SO2 molecules in 64 grams of sulfur dioxide. How many SO2 molecules? The same number, 6.022 into 10 to the power of 23 sulfur dioxide molecules in 64 grams of sulfur dioxide. So, we have completed this. What is emphasized from the above sentences? What can you understand? You know that if you take either an element or a compound equivalent to its molar mass, then the basic number of units contained in that is equal to 6.022 into 10 to the power of 23. That is a constant, and that is what we call as Avogadro constant. So, if we explain that the basic units present in 1 mole of any substance is a constant. So, we use the term basic units. Here you can see it's the atoms. Here you can see it's the molecules. So, it can be atoms, molecules, or even ions if it is an ionic compound. So, the basic units present in 1 mole of any substance is a constant, and it is known as what? Avogadro constant. Constant that is equal to 6.022 into 10 to the power of 23. That is what we have written here. So, do you all understand this? What is emphasized from the above sentences? Then the next question. Extra question 4. Calculate the number of moles of the substances given below. And the relative atomic masses are given to you. Then it's easy for you to do the calculation. I will do for the first one, 88 gram of carbon dioxide So first you need to write the chemical formula or the molecular formula, CO2. Then you know carbon is 12 relative atomic mass, and there are 2 oxygens, and the relative atomic mass is 16. So then 12 plus 2 into 16, you know the value will be 44. If it is molar mass, you have to use the unit gram per mole. So then what is the equation you use? Moles equal mass over molar mass. Mass is what? 88 grams. What is molar mass? 44 grams per mole. So when you calculate, what is the value? It will be 2 moles. That is the number of moles of CO2. Then what is the next one? Ammonia. 51 grams of ammonia. So again, we will write the chemical formula NH3. What will be the relative molecular mass? Nitrogen 14, 3 hydrogens into 1, so that is 17. Then if you calculate the number of moles, I am not going to rewrite it again and again because we are doing all the calculations together. But if you are given just one question, always write the equation and do the calculation. So here mass is given to you 51 grams divided by what? 17 grams per mole. So what is that equal to? This will be 3 moles. 51 divided by 17, 3 moles. So that is the next one. Then we will look at the third one. 234 grams of sodium chloride. What is the chemical formula here? NaCl. Sodium you can see is 23, Cl is 35.5. So the value will be 58.5. Then what do we do here? We need to calculate the number of moles. 234 grams divided by 58.5 grams per mole. So that is going to be, you can see it's 4 moles. So now you are very thorough with the way to calculate the number of moles. Then the next one, 49 gram of sulfuric acid. What is sulfuric acid? H2SO4. So 2 times hydrogen 1 plus sulfur 32 and 4 times oxygen 16. That will be 98. 2 plus 32 plus 4 into 16, 64. So it's 98. Number of moles is what? 49 grams divided by 98 gram per mole. What is that equal to? 49 over 98, 0.5 moles. So is that correct? I am sure yes. So then the last one. 10 gram of sodium hydroxide. What is the chemical formula? NaOH. How do you calculate the molar mass? 23 for sodium plus oxygen 16 and hydrogen 1. So if we add them together, 40. If we write 40 without the unit, that is the relative molecular mass. With the unit gram per mole, it becomes the molar mass. Now you should be very careful with that. Here, number of moles is equal to 10 gram divided by 40 gram per mole. So 1 over 4. That will be equal to 0.25 moles. Is that correct? Did you get everything correct? I am sure you all did. So now you know how to do this calculation. 88 grams of CO2 is equal to 2 moles. 51 grams of ammonia is equal to 3 moles. 234 grams of sodium chloride is equal to 4 moles. 49 grams of sulfuric acid is equal to 0.5 moles. And 10 grams of sodium hydroxide is equal to 0.25 moles. Then I will move on to the next question. Extra question 5. Complete the table given below. The elements are given, relative atomic masses, then you have to find, or sometimes the molar mass is given, you have to find the relative atomic mass, number of moles and mass in grams. So here you need to connect all these values together. We look at the first one. Aluminium, relative atomic mass 27. So what is the molar mass? The same value, 27. Only thing, you have to write the unit gram per mole. The number of moles is not there, but the mass in grams is given to you. So what is the equation we use? You know, N is equal to mass over molar mass. That is what you have to use here. So I'm not going to write the equation because it's written here. I will only do the calculation. So 54 grams divided by 27 gram per mole. So that will be equal to 2 moles. That is the answer there. I am sure you can do it that way. Then let's look at the second one. Nitrogen. You have to write the relative atomic mass. Already you might remember the value by now, but here it's given 14 grams per mole. So here we write it without the unit. Then in this, the number of moles are given 0.5. But you have to find the mass in grams. So what do you do? N in equals mass over molar mass. So if you want to find the mass, what can you do? If you multiply N by molar mass, you will get the mass of the substance. You know that, just rearranging the equation. So here, this is going to be 0.5 moles multiplied by 14 gram per mole. So that is going to be 7 grams. Very easy. You have to remember the equation. And depending on the values given to you, you need to rearrange the equation. I am sure you are familiar with that method of rearrangement. Then sulfur, 32. So molar mass is 32 grams per mole. Number of moles is 0.5. So how do we find the mass? Number of moles 0.25 into 32. That is going to be 8 grams. So 32 grams per mole is the molar mass. So if you have 0.25 moles, the mass in grams will be 8 grams. Then chlorine. Here it is atom, Cl, atom only. 35.5 grams per mole. So the relative atomic mass is 35.5. Then here mass is given 71 grams. So what do? We divide 71 by 35.5. That will be equal to 2 moles. So that's how we find the number of moles. Then the last one, potassium, 39. So molar mass is 39 grams per mole. There are 5 moles of substance. You need to find the mass. So 39 into 5. That will be equal to 195 grams. That is the mass of 5 moles of potassium. Now, do you all understand how you will need to modify the equation? Modify in the sense you have to rearrange. If you are given the mass and molar mass, you find the number of moles. If you are given the number of moles, you know to calculate the molar mass, then you can find the mass of the substance. Those are the calculations. So with that, I will move on to the next question. Extra question 6. Again a similar question. Complete the table given below. Here the relative atomic masses are given to you. Hydrogen 1, carbon 12, nitrogen 14, oxygen 16, sulfur 32 and calcium 40. This is given in your textbook also. But again with the question, the values are given. You have compounds, you need to write the chemical formula, then the relative molecular mass has to be calculated. Again, number of moles and mass of the substances are given. You need to fill in the spaces. So, we'll start with the first one. Carbon dioxide, very easy for you all. CO2. Relative molecular mass, carbon 12, oxygen 16 into 2. That is 44. Here do we write a unit? No. Why? Relative molecular mass. So then 2 moles. We need to calculate the mass. Again you know moles is equal to mass over molar mass. The same way moles into molar mass is the mass of the substance. So mass of the substance 2 into 44. That is 88 grams. You can remember doing this calculation before also. Then we have nitric acid. What is that? HNO3. Relative molecular mass, hydrogen 1, then nitrogen 14. There are 3 oxygens into 16. So that will be equal to 63. 3 into 16, 48. 63. That is the relative molecular mass. Then there are 63 grams. So just by looking at the value, you know it has to be 1 moles. But here you have to show the working. 63 divided by 63. So that is going to be 1 mole. Then the next one, sulfur dioxide. Sulfur dioxide, what is the chemical formula? You are used to it now, SO2. Then how do we calculate the relative molecular mass? Sulfur 32. There are 2 oxygens into 16. So that will be equal to 64. There are 0.5 moles of sulfur dioxide. So how do we calculate the mass? 0.5, the number of moles into 64. Then it is 32 grams. Here you have to write the units. I am sure now you can understand what I am doing here. Right? Okay. Then calcium carbonate. CaCO3. How do we calculate the relative molecular mass? Calcium 40, carbon you can see is 12, and oxygen, there are 3 oxygens, and the relative atomic mass is 16. So when we calculate it, it will be equal to 100. Students, I am going a bit fast. Why? Because we have already calculated the relative molecular masses for most of these compounds before. CO2, nitric acid, SO2, calcium carbonate, everything is familiar to you. So, you know the way of calculating. Then to find the number of moles. Moles is what? Mass over molar mass. What is that going to be? 0.25 moles. So 25 grams is equal to 0.25 moles of calcium carbonate. The last one. What is the last one? Water. a very simple compound that you know very well, H2O. So 2 hydrogens into 1 plus 1, 16. So that is 18. 10 moles of water. So you have to multiply 18 by 10. That is equal to 180 grams. That is the mass of 10 moles of water. So I'm sure you were able to do all these calculations. If you had any doubts with all these calculations, now it will be clear to you as to what you have to do. The same equation, mole equals mass over molar mass. Is that okay, students? Yes. So then the next one. Extra question 7. Briefly explain the following terms. So you have to give a very short explanation. What is the first one? Avogadro constant. What is that? The number of building units present in 1 mole of any substance. So here we can say the number of building units in 1 mole of substance. So why do we use the term building units? Because it can be atoms or compounds. Again, it can be atoms of elements, compounds of molecules of elements, or molecules of compounds. So we say Avogadro constant, the number of building units in 1 mole of substance. What is molar mass? Again, the mass of 1 mole of substance. So here, the mass of 1 mole of substance. That is molar mass. So here you have to briefly explain. So we don't have to go into detail. What is formula mass? The relative molecular mass calculated using the empirical formula of an ionic compound. So formula mass is the relative molecular mass calculated using the empirical formula of an ionic compound. So you know what an empirical formula is. The ratio, the simple ratio between the ions, the positive ions and the negative ions of an ionic compound. So when you calculate the relative molecular mass using the empirical formula, we call it the formula mass. What is the other name? The relative formula mass. Then the next question. What is the unit of molar mass? That is very simple. You know that. What is it? Grams per mole. The unit of molar mass. Mass of 1 mole of substance. So grams per mole. Grams per mole. Then the next question. Extra question 8. Again, complete the table given below. Relative atomic mass is given for helium 4, fluorine 19, magnesium 24, phosphorus 31 and calcium 40. So the substance is given, molar mass has to be calculated, number of moles and number of atoms present in that substance. So the first substance is 2 grams of helium. Now we will write the chemical formula or the symbol here. Helium is He. So that is an atom, monoatomic gas. So what is the molar mass? Helium is 4, relative atomic mass. So this has to be 4 grams per mole. Then number of moles and number of atoms. Here they have given you the substance, that is 2 grams of helium. You already know the equation for moles. Moles is equal to mass over molar mass. So here 2 grams divided by 4 gram per mole. So that is 0.5 moles. In 0.5 moles, how many helium atoms are there? What do you do there? You have to multiply the number of moles by Avogadro constant. So here it's going to be 0.5 into 6.022 into 10 to the power of 23. So that will be 3.011 into 10 to the power of 23. That is the number of helium atoms in 0.5 moles of substance. Then the next one, 10 gram of calcium. So here again you know calcium. What is the molar mass? 40. Why? You can see calcium is 40 grams per mole. Then what do we need to do? We need to find the number of moles. 10 grams. 10 divided by 40. I'm not going to substitute with the units here due to the space, and since I have already done it here, I'm going to do only the calculation and write the final unit. 10 divided by 40, 0.25 moles. So then what is the number of atoms? 0.25 into 6.022 into 10 to the power of 23. So that is equal to 1.504 into 10 to the power of 23. So 1.5 into 10 to the power of 23 is the number of calcium atoms present in 10 grams of calcium, that is equal to 0.25 moles. Then 38 grams of fluorine. What is the atomic mass? That is 19. So what is the molar mass? 19 grams per mole. Then what is the number of moles? 38 divided by 19. So that is 2 moles. Then what are the number of atoms, fluorine atoms? 2 into 6.022 into 10 to the power of 23. So that is 12.044 into 10 to the power of 23. Now here you all know, students, you can rearrange it and write it as 1.2044 into 10 to the power of 24. Here, since I don't have the space, I will just leave it like that. But you all know how to do the rearrangement or to write it in the standard form. Then the next one, 12 grams of magnesium. 12 grams of magnesium. What is the relative atomic mass? 24. So what is the molar mass? 24 grams per mole. Then we need to calculate the number of moles. Mass, that is 12 grams divided by 24 grams per mole, 0.5 moles. 12 divided by 24. Then the number of atoms, 0.5 into 6.022 into 10 to the power of 23. What is that equal to? 3.011 into 10 to the power of 23. So, is it clear to you all now? With practice, it will be easier to do the calculation. Then the last one here, 31 grams of phosphorus. What is phosphorus? P. What is the relative atomic mass? 31. So the molar mass is also 31 grams per mole. Then we need to calculate the number of moles, the same values. So 31 divided by 31, that is equal to 1 mole. So in both you have to write the units. Then what are the number of atoms? Since it's 1 mole, do you have to multiply and show? No need. It is equal to Avogadro constant, that is 6.022 into 10 to the power of 23. So if it is 1 mole, you don't have to write and show. Why? You know the equation, you know the definition that says the number of building units in 1 mole of substance. So that is Avogadro constant, 6.022 into 10 to the power of 23. So were you all able to get all these correct? I am sure you would have done it correctly. Now there can't be any confusions now. No, everything must be very clear to you all. So with that, I am going to move on to the next question, extra question 9. There is 108 grams of water in the glass, that is shown there. Write the chemical formula of water. Calculate the relative molecular mass of water. What is the molar mass of water? Calculate the number of moles of water present in the glass. How many water molecules are present in 18 grams of water? And how many water molecules are present in the above glass of water? That is what you have to do. So now I am going to do the calculation for the first one. There is 108 grams of water in the glass. So there is 108 grams of water. Write the chemical formula of water. Very simple. It is H2O. Calculate the relative molecular mass of water. Now it is very simple to you also. You need to remember the relative atomic mass. As you know, hydrogen is 1, oxygen is 16. So how do we calculate the relative molecular mass? H2O, there are 2 hydrogens, so 2 into 1 plus oxygen 16. So it will be 18. Is there a unit? No unit. Why? Relative molecular mass of water. Is it correct? Yes. So then the next one. What is the molar mass of water? Do you need to calculate it again? No need. You just need to write it 18 grams per mole. You have to give the unit. That's the difference. Relative molecular mass with the unit grams per mole becomes the molar mass. Calculate the number of moles of water present in the glass. What is the equation for moles? N equals mass over molar mass. So what is the mass of water? It's 108 grams. What is the molar mass? 18 grams per mole. So when you calculate, what will be the value? It will be equal to 6 moles. 108 divided by 18. 6 moles of water. So that is what you are supposed to calculate here. Then the next one. How many water molecules are present in 18 grams of water? 18 grams of water is equal to how much? Water equals 1 mole. Why? The molar mass of water is 18 grams per mole. So how many water molecules? Now look at the question. How many water molecules are present? In 1 mole, it is the Avogadro constant. So how many water molecules? 6.022 into 10 to the power of 23 water molecules. So this is the answer you have to write. I wrote these to explain how you get the value. If you write only this, that is more than enough. 6.022 into 10 to the power of 23 water molecules. How many water molecules are present in the above glass of water? We calculated the number of moles. How much was it? Can you remember? Here you can see it's 6 moles. So how many water molecules are present in the above glass of water? You know the moles is 6 moles. So we already know in 1 mole there are Avogadro number of particles. So in 6 moles water molecules equals 6 into 6.022 into 10 to the power of 23. So when you calculate the value 36.123 into 10 to the power of 23. We can slightly rearrange it and write it in the standard form 3.6132 into 10 to the power of 24. So that is the water molecules present in the above glass of water. Is this clear to you now? So this question includes almost all the different types of calculations that you have learned before. So then with that I can move on to the next question. Extra question 10. Quicklime is obtained by heating limestone. Do you know the chemical formula of quicklime and limestone? You know limestone is calcium carbonate. So when you heat, now this delta symbol, the triangle symbol is for heat. What will you get? You will get calcium oxide plus carbon dioxide. Now calcium carbonate is limestone. And this calcium oxide is the quicklime. So quicklime is obtained by heating limestone. A sample of 28 gram of quicklime is shown in the figure below. So this is a sample of 28 gram of quicklime. Write the chemical formula of quicklime. Calculate the relative molecular mass of calcium oxide. The quicklime itself is calcium oxide, CaO. What is the molar mass of calcium oxide? Calculate the number of moles of calcium oxide present in the above sample. What is the mass of 5 moles of calcium oxide? So those are the questions related to this. Now we will answer them one by one. Quicklime is obtained by heating limestone. A sample of 28 gram of quicklime is shown in the figure below. Write the chemical formula. So I showed you all, you know it is calcium oxide. Calculate the relative molecular mass of calcium oxide. So you know calcium is 40 and oxygen is 60. So calcium oxide is equal to 40 plus 16, that is 56. Is there a unit? No. Why? It is the relative molecular mass of calcium oxide. So then the next question, what is the molar mass of calcium oxide? What do you do there? You have calculated the relative molecular mass. You can remember it is 56. So to this we add the unit grams per mole, the molar mass of calcium oxide. Then calculate the number of moles of calcium oxide present in the above sample. So now to find the number of moles, that is equal to mass over molar mass. What is the mass of quicklime given there? 28. So 28 grams divided by what? 56 grams per mole. So you can see this is 1 over 228 divided by 56. So that is equal to 0.5 moles. You know the gram and gram getting cancelled off and the mole goes up, mole minus goes up and becomes mole. So 0.5 moles is the number of moles of calcium oxide present in the above sample. So I am sure you were able to do everything correctly up to here. Then the next one. What is the mass of 5 moles of calcium oxide? So again, what is the equation? Moles equals mass over molar mass. So when you rearrange, mass is equal to moles into molar mass. So here 5 moles of the substance. What was the molar mass? You can remember calcium oxide. It is 56 grams per mole. So then if we calculate, it is going to be 280 grams. Here also the mole and mole minus 1 will get cancelled off. So now you can see the advantage of writing the units. You get the final answer with the unit grams, 280 grams. That is the mass of 5 moles of calcium oxide. Is it correct up to here? Can you all understand the calculation? Yes. So then I am going to move on to the next question. Extra question 11. A person measured 2 teaspoons full of urea as fertilizer for a plant. That was equal to 4.2 grams of urea. That is the data given to you. Again, write the chemical formula of urea. Calculate the relative molecular mass of urea. What is the mass of 1 mole of urea? What is the molar mass of urea? Calculate the number of moles of urea present in the sample, that is 2 teaspoons full. How many urea molecules will be added to the plant from the above? So now that you have been practicing questions, this would have become very simple. You can answer it quickly. We will do that now. Person measured 2 teaspoons full of urea as fertilizer for a plant. That was equal to 4.2 grams of urea. Write the chemical formula. So what is that? You can remember CONH2 twice. CONH2 twice. Calculate the relative molecular mass. So here carbon you know is 12. For oxygen, relative atomic mass 16. Then how many nitrogens are there? There are 2 nitrogens into 14 relative atomic mass. And there are 4 hydrogens, relative atomic mass 1. So when you calculate the value, what do you get? 12 plus 16 plus 28 plus 4. It is equal to 60. Now relative molecular mass. So you don't write a unit. Is it okay up to here? Yes. Then the next one. What is the mass of 1 mole of urea? What is the mass of 1 mole of urea? We have already calculated. 1 mole of urea is equal to what? We calculated the relative molecular mass. Do you just leave it like that? No, they have asked what is the mass of 1 mole of urea. So you have to say 60 grams. Do you put gram per mole? No, that is also not correct. That is the unit of molar mass. You have to answer to the question. What is the mass of 1 mole of urea? So 1 mole of urea is equal to 60 grams. Then the next one, what is the molar mass of urea? So what I just explained, 60 grams per mole. 60 grams per mole. Now do you all get it clearly? The difference. Relative molecular mass, no unit. If they ask you the mass, you have to say 1 mole is equal to 60 grams. And if they ask you for the molar mass of urea, you have to write it as 60 grams per mole. I am sure it's clear to you now. Then the next one. Calculate the number of moles of urea present in the sample. 2 teaspoons full. Can you remember the mass? I will quickly go back and check. 4.2 grams of urea. So this was equal to 4.2 grams. So then what are we supposed to do? Calculate the number of moles. Now you know the equation. Moles equals mass over molar mass. So what is the mass of urea? 4.2 grams. What is the molar mass? We calculated it as 60 grams per mole. So what is going to be the value? It is going to be 0.07 moles. When you divide 4.2 grams by 60 grams per mole, you get the value as 0.07 moles. That is the number of moles of urea present in the sample. Then what is the next one? How many urea molecules will be added to the plant from above? Now you know when you are supposed to relate it to the number of molecules, what do you need to use? You need to use the Avogadro constant. What is the value? 6.022 into 10 to the power of 23. And what do you do there? You multiply the number of moles by Avogadro constant. So urea molecules. You don't need to write the full sentence again. How many urea molecules will be added to the plant from the above? So the number of moles 0.07 into Avogadro constant 6.022 into 10 to the power of 23. So students, when you multiply this 0.07 by 6.022 into 10 to the power of 23, you will get the value as 0.42154 into 10 to the power of 23. So what do we do now? We need to rearrange. It will become 4.215. You don't have to write all the decimal values. You can even write as 4.21 into 10 to the power of 22. That is what is very important because you are shifting the decimal position. So the 10 to the power will change. So the number of molecules, how many urea molecules will be added to the plant from above. So here the number of urea molecules will be equal to 4.215 into 10 to the power of 22. That is the number of molecules. So with that, I will move on to the next one. Extra question 12. 15.9 grams of copper sulphate was dissolved in 100 milliliters of water to prepare a solution for the Biuret test. You know what the Biuret test is. It is the test to identify proteins. You can remember that. What do you understand by the term relative molecular mass? Find the number of moles of copper sulphate present in the solution. Find the number of copper sulphate molecules present in the solution. Find the number of oxygen atoms of copper sulphate present in the above solution. So those are the questions that you need to answer. So I will move on to the first question. What do you understand by the term relative molecular mass? Here you don't write the equation. You have to say what you understand. What is it? Relative molecular mass. What is that? What do you write there? The mass of a molecule of an element or a compound relative to 1/12 the mass of 12,6 carbon isotope atom. Or you can say how many times the mass of a molecule of an element or compound weighs as much as 1/12 of 12,6 carbon isotope atom. That is what you understand by the term relative molecular mass. So I will write that here. How many times a molecule of an element or compound weighs as much as 1/12 the mass of 12,6 carbon isotope atom. So that is what we understand from the term relative molecular mass. Then the next one. Find the number of moles of copper sulfate present in the solution. What was the mass of copper sulfate? 15.9 grams. So here we know the mass is 15.9 grams. What else do you need? You need to know the molar mass. To do that, you should know the chemical formula. I'm sure you know that very well. CuSO4. And what is the relative atomic mass of copper? That is 63.5. Then sulfur is 32. And there are 4 oxygens into 16. So what is that equal to? Again 63.5 plus 32 plus 4 into 16, that is 64. That will be equal to 159.5. And if it is the molar mass, you have to have the unit grams per mole. Then what do we need to calculate? Number of moles of copper sulfate. So what do we do here? Number of moles equals mass over molar mass. Mass is given to you 15.9 grams. What is the molar mass? 159 grams per mole. So you can see the relationship 1 over 10. So 1 over 10, that is equal to 0.1 moles. 0.1 moles of copper sulfate. Find the number of moles of copper sulfate present in the solution. So that is 0.1 moles. Is it correct? Yes. So then the next one. Find the number of copper sulfate molecules present in the solution. We found the number of moles of copper sulfate. So you all know what is the value that you need to use in order to find the copper sulfate molecule. So here it is the copper sulfate molecule. What do you need to use? You need to use the Avogadro constant. So here copper sulfate molecules. Sulfate molecules, that is equal to 0.1 mole into 6.022 into 10 to the power of 23. So when you calculate the value, you will get it as 0.22 into 10 to the power of 22. Why 0.1 and 10 to the power of 23? It becomes 10 to the power of 22. That is the number of copper sulfate molecules present in the solution. Then the next one. Find the number of oxygen atoms of copper sulfate present in the above solution. So here note the question, students. Oxygen atoms of copper sulfate present in the above solution. Why do they say that? Because if it is a solution, you all know there is copper sulfate as well as water. and water also has oxygen. So what are we doing here? We are not considering the oxygen from water. It is the oxygen only from copper sulfate molecules. So find the number of oxygen atoms of copper sulfate present in the above solution. What is copper sulfate? CuSO4. So if you take one molecule of copper sulfate, how many oxygens are there? There are 4 oxygen atoms. Now we have found the number of molecules of copper sulfate there that is present in the solution. So what do we need to do in order to find the number of oxygen atoms? We need to multiply this by 4. So here number of oxygen atoms, that is equal to 4 times 6.022 into 10 to the power of 22. So when you calculate the value, 24.088 into 10 to the power of 22. So if we rearrange this to get the standard form, you will get the value as 2.4088 into 10 to the power of 23. So that is the number of oxygen atoms present in copper sulfate, that is present in the solution. Is that clear to you all now, students? So first we calculated the number of moles of copper sulfate, then we calculated the number of copper sulfate molecules, and then the number of oxygen atoms present in that solution. That is not considering the water molecules. With that, I will move on to the next one. Extra question 13. Mass of an atom of an element X is 3.2 into 10 to the minus 24. You are familiar with this type of question. Value of the atomic mass unit is 1.6 into 10 to the minus 24. So here the element is X. What do you understand by the term atomic mass unit? Find the relative atomic mass of element X. What is the molar mass of element X? There is 20 gram of X in a container. Find the number of moles of X in the container. So we can do those calculations now. What do you understand by the term atomic mass unit? What is atomic mass unit? 1/12 the mass of 12,6 carbon isotope atom. So 1/12 the mass of 12,6 carbon. You don't even have to say isotope, 12,6 carbon atom. That is atomic mass unit. Then what do you need to find? Find the relative atomic mass of element X. So relative atomic mass of element X. What is that equal to? Mass of an atom of X divided by 1/12 mass of 12,6 carbon atom. That is what you have to calculate. You need to use this equation. Now I want to check the mass of element X. If we go back, it is 3.2 into 10 to the minus 24. But here, the atomic mass unit is given to you. 1.6 into 10 to the minus 24. So, what do we have here? 3.2 into 10 to the minus 24 grams. Divided by, they have given you this calculated value. This whole thing is given to you, that is equal to 1.66 into 10 to the minus 24 grams. That is given to you. So then we don't have to calculate it again. So I can directly substitute the value as 1.6 into 10 to the minus 24 grams. It's 1.66, but in the question they have given it as 1.6. So it's easy. Gram and gram cancels off, 10 to the minus 24 and 10 to the minus 24. When you divide 3.2 by 1.6, you get the answer as 2. 2 is the relative atomic mass of element X. So that is the calculation. Then the next one. What is the molar mass of element X? So we calculated the relative atomic mass as 2. So what is the molar mass? 2 with the unit grams per mole. Then the next one. There is 20 gram of X in a container. Find the number of moles of X in the container. Again, moles, you can use the symbols or the word equation, mass over molar mass. What is this? You know the mass? 20. So 20 grams divided by molar mass, 2 gram per mole. Very easy calculation. The answer will be 10 moles. 20 divided by 2, 10 moles. So I am sure you were able to answer all these questions. Then the next question. I am going to move on to the next question. This is extra question 14. Select the most suitable answer. So you know these are the MCQ type questions. Number of sulfur atoms in 16 grams of sulfur. So the relative atomic mass of sulfur is given to you 32. Then you need to calculate the number of moles, mass over molar mass, 32 grams per mole. You can see the value is 0.5 moles. So in 0.5 moles, how many sulfur atoms are there? When you multiply for atoms, 0.5 into 6.022 into 10 to the power of 23. What is that equal to? 3.011 into 10 to the power of 23. Can you find the answer here? 6.022 into 10 to the power of 23? No. 3.011 into 10 to the power of 23. That is correct. What is the difference here? 3.011 into 10 to the power of 22. So that is not the answer. 6.022 into 10 to the power of 22. That is also not correct. So it is the second answer. Then the second question. Number of basic units in a mole or Avogadro constant is. What is the number of basic units? What we just use now, 6.022 into 10 to the power of 23. First one, 1.67 into 10 to the power of 24. No. 6.022 into 10 to the power of 23. Correct. Third one, 6.476 into 10 to the power of 23. No. And the last answer, 3.819 into 10 to the power of 23. It is the second answer. Then the next one. How many sodium carbonate molecules are found in 53 grams of sodium carbonate? So here if you look at the answer, students, you can see answer is in the equation form. So there you know what the values are. You know 6.022 into 10 to the power of 23 is the Avogadro constant. Then this 53 is given to you 53 grams. Then what should this 106 be? That is the molar mass of sodium carbonate. Here you can see there are 2 sodium atoms. So 2 into the molar relative atomic masses are given to you. 2 into 23 plus 12. And there are 3 oxygen. So 3 into 16. If you calculate this, you will see 46 plus 12, 58 plus 48. That will be equal to 106. So, that is the relative molecular mass or molar mass of sodium carbonate. 106. What is the reference? If it is relative molecular mass, it's only 106. If it is molar mass, it's 106 grams per mole. So, you know the values. Now, you have to see which equation is correct. So, we are supposed to find the sodium carbonate molecules. So, to do that, what do we need to know first? The number of moles of sodium carbonate. So, how do you get the number of moles here? To calculate the number of moles, that is, number of moles is equal to mass 53 divided by 106 molar mass. Then what do? We multiply by Avogadro constant, 6.022 into 10 to the power of 23. So, that is the equation that you need. So, after you do that, it will not be the number of moles, it will be the number of molecules of sodium carbonate, that is 8. So, can you find that equation here? Now, look at the first one. The values are in different order, but it is the same thing. 53 divided by 106 into 6.022 into 10 to the power of 23. So, that is a correct equation. Here, what has happened? Now, the 53 and 106 have been switched. So, that's not the correct equation. Here, they have the 53 multiplied by 106 on top. So, that is also incorrect. Then again, here 53 into 53. So, for a question like this, if you know what the equation is, then it is easy for you to select the answer, the first answer. That gives you how many sodium carbonate molecules are found in 53 grams of sodium carbonate. Is that clear to you all? Okay, so it is the first answer. Then the next question. The substance that is equal to 1 mole. So, here they have given you all 4 different substances and different masses. You have to find what is equal to 1 mole. So, to do that, we will have to calculate and see. What is the first one? Hydrogen atoms in 2 grams of hydrogen gas. So, what is hydrogen gas? Now, that is H2 gas. So, in hydrogen gas, there is 2 grams. So, what is the molar mass of hydrogen here? If you calculate, there are 2 hydrogens. So, 2 into 1, that is 2 gram per mole. If you calculate the number of moles of H2, what is that? That is again 2 divided by 2, that will be 1 mole. But look at the question carefully. They want you to find the hydrogen atoms. Now, this is the number of moles of hydrogen gas. That is 1 mole. But if you take the number of moles of hydrogen atoms, you can see there are 2 hydrogens in 1 molecule. Therefore, there will be 2 moles of hydrogen atoms. So, this is not correct. Then we have to look at the second one. Oxygen atoms in 8 grams of oxygen gas. Again, a similar calculation. So, if we do the calculation now, oxygen atoms in 8 gram of oxygen gas. So, what is O2 gas? It is O2. Then, if you calculate the molar mass, oxygen is 16, there are 2 oxygen atoms, so it will be 32 grams per mole. Then if you calculate the number of moles of O2, it's 8 grams divided by 32 grams per mole. So, how many moles of oxygen gas are there? 8 over 32, 1 over 4 or 0.525 moles. That is the number of moles of oxygen gas. But what does it say here? Oxygen atoms. So again the same thing, number of moles of oxygen atoms. What will that be equal to? 0.25 into 2, that is 0.5 moles. So that is also not correct. Then look at the third one, water molecules in 8 grams of water. So if we do the next calculation, water molecules, now it is 8 grams of water. What is the chemical formula? H2O. So if you calculate, you know 2 times hydrogen plus oxygen 16. So that is equal to 80. So if we calculate the number of moles of water, you will see 8 over 18. It is somewhat not even equal to 0.5. So this is about 4 by 9. That will be 0.4 moles. So that is also not correct. Now we are left with one more answer. We have to check whether that is correct or not. So I will do the other calculation on this side. Methane molecules in 16 grams of methane. What is methane? CH4. So if it is CH4, carbon 12 and 4 times hydrogen, so that is 16 grams per mole. Then if we calculate the number of moles, CH4, what is it? That is also 16 grams divided by 16, that is 1 mole. So what was the question again? We are supposed to find the substance that is equal to 1 mole. So this is correct. So that is the answer there. So now do you all know how to calculate here? When you are given a question, for each one you have to calculate and see. So hydrogen, that is hydrogen atoms 2 moles. So not correct. Then oxygen atoms, it becomes 0.5 moles. Then again water, it becomes 0.4 moles. And there CH4, the molecules, that is equal to 1 mole. So that is what we have to select here. Then with that, I will move on to the next question. Number of molecules contained in, so here again, number of molecules contained in 5 moles of water. How do you find that? The number of moles into Avogadro constant. Why? Always there is Avogadro constant number of atoms or molecules in 1 mole of substance. So here if you look at the answer, 6.022 into 10 to the power of 23, that is Avogadro constant. That into 5, that is number of moles. So that is the correct answer. But we will look at the others. Now here you can see Avogadro constant into 5, but they are dividing it by 18. That is not necessary. So it's not correct. Here if you look at it, they are multiplying by 18 and dividing by 5. That is also not correct. Then here this only gives the Avogadro constant. So we have selected the correct answer, the first answer. Then the sixth one, relative atomic mass of sodium. So for that they have given mass of sodium atom 3.819 into 10 to the minus 23. Mass of carbon atom 1.993 into 10 to the minus 23 grams. So the values are given to you. How do you find the relative atomic mass? Mass of an atom of sodium divided by 1/12 the mass of 12,6 carbon atom. So here this is mass of sodium atom, correct? This is the mass of carbon atom, but there is no 1/12. So that is not correct. Here if you see, they have multiplied the masses. That is also not correct. Then here again, it's the other way around. Mass of carbon is on top, mass of sodium is at the bottom. That is also wrong. If we look at the fourth one, this is the mass of sodium, 3.819 into 10 to the minus 23. That is correct. Then 1/12 into 1.993 into 10 to the minus 23. That is correct. So that is the correct answer. The fourth answer is the correct answer. I am sure you are familiar with these types of questions. If you are given the equation, you have to look at it carefully and select the correct answer. With that, I will move on to the next one. Number of carbon atoms in 2 moles of carbon dioxide. So, we need to find the carbon atoms in 2 moles of carbon dioxide. So, if you take carbon dioxide, it is 2. In 1 molecule of carbon dioxide, there is only 1 carbon. So, this has only 1 carbon. But there are 2 moles of carbon dioxide. So, there should be 2 moles of carbon. And you know what you need to do to find the number of molecules or number of atoms here. Number of carbon atoms in 2 moles of carbon dioxide. So, what do you need to do? You need to multiply by Avogadro constant. So, look at the answers. 6.022 into 10 to the power of 23, that is Avogadro constant, but it should be multiplied by 2 into 6.022 into 10 to the power of 23. So, if we look at the answer, the second one, 2 into 6.022 into 10 to the power of 23. That is correct. Third one, 6.022 into 10 to the power of 24. There the power is different. And the fourth one, 3.011 into 10 to the power of 23. There the value for Avogadro constant is different. So, the correct answer is the second one, 2 into 6.022 into 10 to the power of 23. Then the next one, unit of molar masses that we have been using. We look at the answers, moles per gram. We didn't use a unit like that. Grams per mole, that is correct. Mole minus 1, no. Mole kilogram minus 1, that is also not the answer. So, the correct one is grams per mole. So, is that okay, students? Then I will move on to the next question. Molecular formula of glucose is C6H12O6, that is given to you. The mass of 1 mole of glucose is, here you are supposed to calculate the molar mass, that is the mass of 1 mole of glucose. So, if we calculate, there are 6 carbons, so 12, 6 times 12, plus there are 12 hydrogens, 12 times 1, and there are 6 oxygens, 6 times 16. So, what is the value? This is 72 plus 12 plus 96, and that will be equal to 180 grams per mole. So, the mass of 1 mole of glucose is 180 grams. So, you can find the answer now. First is 180 grams, 90 grams, 270 grams, 45 grams. So, it's the first answer. We have calculated the value. But here, the unit is grams per mole. Why? That is the molar mass. So, that means it's the mass of 1 mole of glucose. So, that is why here the units are given in grams. Do you all understand that? Yes. So, then the 10th one. The relative atomic mass of iron is given to you. So, iron is 56. Select the correct statement. So, you have to select the correct statement. The mass of an iron atom is 56. Is that correct? It is the relative atomic mass of iron, that is 56. In one amount like that, 56 grams, there are the Avogadro number of iron atoms. So, here they say the mass of an iron atom, one iron atom. That's wrong. So, this is wrong. Then a mole of iron contains 56 iron atoms. Is that correct? A mole of iron. 1 mole of iron contains 56 iron atoms. That is also wrong. It has 56 grams of iron, not 56 iron atoms. Then the mass of 6.022 into 10 to the power of 23 iron atoms is 56. That is correct. Why? 56 grams is equal to 1 mole, and in 1 mole there is Avogadro number of iron atoms. So this answer or this statement is correct. Then the fourth one, the mass of 56 iron atoms is 6.022 into 10 to the power of 23. That is also wrong because you know this is the Avogadro constant. So that is wrong. Then the correct answer is the third answer. So those are the MCQ or multiple choice type questions. So I am sure now you all have an idea as to how you will get questions related to this lesson. So with that, students, I have come to the end of discussion of this lesson. That is the 7th unit of your science textbook. So I'm sure now by now you know how to do calculations, but that is not enough. Practice as many questions as possible. Then you will be very competent to answer any type of questions.